The broadcast is now starting. All attendees are in listen-only mode.
All right, ladies and gentlemen, welcome to the webinar, KBR, As-Built Best Practices from one of the world's largest EPCs. We've got a great show today. If it's your first time joining us, welcome. You picked a perfect time to start attending these webinars. If you've been to one or two before, or even several, welcome back. It's the perfect time to return. Before we get too deep into things, let me go ahead and go over kind of the ground rules of the webinar here. All viewers are going to be muted for the duration of the presentation. Myself and my co-host here will be kind of going over these case studies and giving you the down low. Of course, any questions, comments, any clarification you'd like, you can ask through the questions panel in GoToWebinar. And of course, at the end, we'll be answering those questions in our Q&A session. If you have to dip out for some reason, meeting, something like that, the webinar is being recorded, and we'll send you a link as soon as we're finished here so you can rewatch it for posterity. My name is Jason Moran. I'm the Edgewise product manager at ClearEdge 3D, and with me we have Derrel Shaffer, who's the As-Built service manager with KBR, who, as I said before, is one of the world's largest EPCs. Derrel has a huge body of work. He's got a wealth of experience and knowledge about the industry as a whole. Typically for these webinars, we have 2 or 3 presenters, but when we got to look at the projects Derrel was going to present, we decided it was just good enough that he could get his own webinar here. So why don't you say hi, Derrel?
Hi, I appreciate it. I appreciate the opportunity to present a few of the things that we've done in the past as far as laser scanning and 3D modeling.
Absolutely. All right, well, without further ado, let's get into it here. Take it away, Derrel.
Okay. First of all, I just want to mention, I know many people are doing laser scanning in a lot of different industries, that I'm going to be focusing exclusively on what we do. It's industrial. And so I think many of the things we do are applicable, but they are specific to industrial services. Next slide, please. To give you an idea of who KBR is, how big we are, we're about 34,000 people, and we have an office in about 75 countries around the world. And so this kind of gives you a global footprint of where we're at. Next slide. Basically, our company is broken up into 3 business groups, where our technology and consulting groups, they handle some of our proprietary technologies and even equipment designs, process designs. The hydrocarbon services is what my group is in, although it's a lot bigger than just hydrocarbons. So I'll talk about what we do later, but it's more than just oil and gas. And then we have government services. I will point out too, KBR does in some of our locations work in, I would say, dangerous areas or areas that, well, anyhow, like areas like Iraq we have in the past, or Afghanistan, Nigeria, and some difficult places that we work in, and we have a lot of experience in working in those complicated, dangerous areas. Next slide, please. This is just, I'm going to read it. It's just kind of what we do, and so this is the offering our company offers. Okay, next slide. This slide's just a little bit about who I am. I'm actually a registered structural engineer, but I haven't been doing that in quite a while. I have about 35 years of experience over a lot of different industries that I've worked for in the past. I've done about 450 projects since 1996. And one of the things that I did do is I participated when I was with Raytheon Engineers and Constructors and with Washington Group with field testing the Cyra systems scanner, started in '96, both their alpha and their beta systems. And what you see on the screen is the alpha system. And you can see the huge electronic box that was with that original scanner. Of course, these days we have scanners that basically fit in the palm of your hand. But then the beta system that finally came out of that ended up being the Cyra 2400 system, which Cyra was bought, or Cyra Technologies was purchased by Leica Geosystems in 2001. And so that was kind of the origin of the Leica scanner, is through the Cyra Technologies company that they acquired. Next slide, please. Just a little bit about my group, and I should note right off the bat that we do have another office in Sydney, Australia, who deals in other industries than we do. They're more into infrastructure, rail, water treatment, sanitary treatment type projects. They have similar workflows than ours, but they're a little bit different. But I'm going to specifically talk about what we do and how we actually implement projects, both scanning and 3D modeling. Our primary industry is we do work in oil and gas, chemical, and pulp and paper. We do, as far as services we offer, we do a dimensional control survey. We do laser scanning. We do 3D as-built modeling, 2D as-built drawing creation. We also do installation and removal studies, which is predominantly we're working with projects and construction where they have complicated scenarios as far as equipment removal and installation. And we also do new fabrication, construction verification. So in that case, what we're doing is usually doing critical pipe spool surveys, equipment surveys, vessels, modules, all those types of things where critical fit up once these pieces of equipment or weldments come to the field, they need to fit up without any problems, and it's assuring the project that there will be no problems or delays. We predominantly support our global engineering and construction projects, and we also support a lot of our clients have us come do the scanning for them when they have other needs that are actually not part of KBR's engineering construction, but it's for plant requirements of what they need to do with the data. And one other thing too, as far as the 3D modeling is concerned, we do have a high-value Monterrey, Mexico office, and we utilize them also to help us be cost-effective in a lot of the 3D modeling that we do. Next slide, please. This slide just gives you an idea of the equipment that we have. Again, some of this equipment is in our Australia office. And I should mention also our Australia office, they predominantly support the Asia Pacific area, where our office is supporting the US, the South America, Central America, and Europe, a lot of European projects. But anyhow, this shows the equipment that we utilize. Just to talk about what some of the software that we utilize, and almost all the software and the hardware we use is predominantly Leica. But we use Register and as predominantly do our registration, which I think I'm going to be talking about that in another slide, so I'll stop there. But we also have 3 seats of the Edgewise software, which we use, of course, for our modeling, and I'll go into detail about how we use that. Our predominant systems that we're delivering into is Integraph PDS or Smart Plant 3D, and also a Viva PDMS. Those are the predominant engineering systems that we're delivering both scan data and models to. And just to point out a couple things on some of the instruments we use, we have one instrument called a Leica Nova MS60. It's a 1-second multi-station, and that instrument is the merger of both scanning and a high accuracy surveying instrument. This is the instrument that we'll use when we need basically millimeter accuracy. So a lot of our shop validations that we do, like I have a person that will be going to South Korea to a shop to validate a vessel just after Christmas. And this is the instrument he'll carry on board with him. And so it does both scanning and it does surveying, and it's very precise in the point cloud it collects. The other instrument I want to talk about here is the Leica BLK360. And what we've done with that is we're putting right now one of these in most of our offices, and it's basically a system that can be checked out by our engineers and utilized for a lot of small projects. Now, in a minute, I'm going to talk about us using survey predominantly and target-based registration, but with this instrument, we're using cloud-to-cloud registration, but we're restricting the usage to a more small area. When we use cloud-to-cloud registration. So this instrument allows us to drive laser scanning down to the very smallest jobs, and it's being used exclusively by the engineers and designers. We give them about a 15 to 20-minute course on how to use it, how to set the instrument up, and how to make sure that we're going to have an easy registration process when they bring the data back. And then they take it with them, and we also have a flight case that can go with it too, so they can carry it on board very easily as checked luggage. So next slide, please. I just mentioned a minute ago that almost all of our work, we use dimensional control and a survey network. And part of the reason we do that is the survey target-based registration is required by most of our clients. They require 100% target-based registration for our scans. And when I talk about that, I'll get into detail about that in a minute. But this is basically for precision relative to positional precision relative to the coordinate system. And the way we do that is we use our survey instruments are either 1 second or 2 second instruments. And we're using onboard resection software on these instruments to allow us to set each station of our survey instrument precisely. And in that software, it's also doing a least square adjustment to the survey position, so that we get very tight positioning when we're actually setting up our stations doing our survey. And then we also will try, when we're using resection method to do our survey, we will actually come around and try to close the loop and see our error, which is amazingly low on these instruments by using this 5-point resection method. We also have in the past done traditional land surveying, setting up over a known point and backsighting, but predominantly we will use this type of survey, but we can do typical land surveying if that need be. However, I will point out we are not PLSs, so we do not do legal surveys. Scan registration software, we use Register, Leica Cyclone Register, and Register 360. Register 360 is basically only used for a BLK 360 laser scanner, where it does semi-automatic registration, cloud-to-cloud registration, or targets if they're in the scene. And it does a very good job as far as maybe doing as many as 50 scans. But we always finish off by bringing it into our register software and finalize the registration at that point within the Cyclone Register software. Scan registration, again, I've mentioned we do 100% surveyed target-based registration. So wherever possible, we are using our survey network and targets to position every scan. We make sure, too, that we are surrounding the scan with the targets wherever possible. That will maximize the accuracy. If you cluster targets on one side of the scan, you're compromising the accuracy slightly, and an accumulation of that could be a little bit of a problem. So, we try to follow that method. We only use cloud-to-cloud registration other than the BLK 360 on a limited basis. So we will use it if our target positions are not surrounding the scan, or if we're in a position where we can't get the survey in, we will definitely use cloud-to-cloud registration if necessary to or overscanning targets to actually get into tight areas where survey can't easily be brought in. What we maintain in our SOP is about a 6 millimeter maximum single target error. So in other words, any one target that exceeds 6 millimeter, and we're generally shooting for 4 to 5 millimeters, we will throw out because of the inaccuracy. And in an entire registered bundle, we'll hold that error to about 3 millimeters for the bundle. And almost, we never have a problem really by doing this. It's rarely been a problem where we've exceeded this. The only difficulty becomes when our targets are far away consistently from the scanner. Then meeting those error targets or allowables can be a little more difficult. As far as the QA report we do, I feel this is very important, and every service provider ought to be doing this because I've seen problems over the years. One of the first things it does for us is it does a sanity check to make sure our plant coordinate system verifies with what some known coordinates are, for the facility. So we're basically just, indicating in one column, here's the coordinates of the theoretical position of this object. Here's the coordinates, like, for example, the center of our column. And here's the coordinates that we surveyed, and that's in our registration position, then here's the deviation. And what happens is when we do this, we can understand where the problems occur, and many times plant benchmarks are not necessarily reliable, and this will highlight that problem. Or we'll have buildings that are not where, or at least associated buildings. So you have one building that appears to be in the right coordinate system, and then you go outside to another building, and it's not where the drawings show. And this QA report, which we do across the area, helps identify those problems early before we begin finalizing the scan data or start doing 3D modeling. This QA report is given to our client also, our internal or external, and they get to see it also so that they can have confidence that our data is reliable. We also, now these scan bundle errors that I'm talking about, the registration error report, they're very lengthy. So all we do is include the very front page that gives a summary, and in that it will reveal the enabled error of the targets. And so the client can see, okay, for our entire registration in this group, this is our enabled target error. And so he can clearly see the registration is very tight. And again, like I mentioned, customer review and approval is required for us to make sure they're on board where we're at and feel satisfied with the data they're getting. Next slide, please.
Sure. Real quick before we move on, we have one question.
Yeah.
Just on the last slide, you mentioned only using the BLK 360 and cloud-to-cloud registration on a small area. Can you define what that small area is?
Yeah, that's hard to define, actually, in a way. So there's no doubt about it. You can go a few bays, where a bay is 20 to 25 feet, in each direction. You can go a few bays and not have a problem. You may actually be able to push 5 or so bays. But what I've actually seen happen, and here's an example. There was an engineer who checked out the scanner, and he decided, I'm going to save some money, and I'm not going to get some, the surveyors and the scanner guys out here. I'm going to do it all myself. So what he did was he went down a line with a BLK 360, my memory, it's somewhere in the order of 70 scans or so. Well, what happens is that accumulated error that you get from going scan to scan to scan to scan, what happened was when you got about 3/4 of the way down, a curl began to happen going upwards of those scans. So by the time you got to the last scan in the linear group of scans, there was probably a 4-inch raise in the elevation as that upward curl was occurring because of that accumulated error along the way. So what we did in that case was we basically broke the scan, used the coordinates of the columns that were in that last part of the area, and basically twisted the whole group down for that last group. So you just need to realize that cloud-to-cloud registration, while very accurate in smaller areas, as you begin to move down the length of an area, you're going to probably accumulate error. And so you need some kind of survey or something to actually correct that error. Long-winded answer, I'm sorry, but that's basically, why I would say you want to keep it to small areas.
Sure. That makes perfect sense. And what resolution are you scanning at here?
Okay, most of our, now to be honest with you, when you're looking at the large scanners, we're normally at 6.3 millimeters by 6.3 millimeters at 10 meters. When we're looking at the BLK 360, because we're trying to equate the total number of points to our large scanners, so on that, we're normally scanning at high resolution, which actually delivers more points than, so in other words, a typical scan, let's just assume we don't have sky where points go away, maybe as high as 35 million points or so. You'll get approximately 50 million points on a single BLK 360 scan because it is at a higher resolution. But if you go to the medium setting on a BLK 360, you're down to 12 million points. So we're trying to equate to what you would get on the bigger scanners. However, I will say this: if you're confined and you're within a small area where you're not looking at any kind of distance, of course, the lower resolution is just fine. It's just we're trying to equate it to if we were using our bigger scanner.
Sure, and it's probably better to collect extra data up front and decimate it in the office than to have to go back out in the field because you didn't scan enough.
Yep, we're processing true view images. Those, the higher the scan count, the better the resolution. So that extra scan count gives a much more higher resolution, gives a higher resolution photo image that comes from it.
Absolutely.
Okay.
All right.
Next slide, please. Okay, well, just to talk about how our workflow as far as 3D modeling workflow. Generally, what we do is we will initially, as soon as the registration is complete, we've been through the QA, everything looks good, we will process out the Edgewise databases. And normally we'll have one guy working on doing pipe runs and conduits down to 1-inch diameter minimum. If possible, we try to go to 2 inches. It just takes more time, the smaller diameter or smaller bore pipe that you're going down to. We will also do structural steel modeling within that software because it's superior to any kind of software we've found regarding doing structural steel in the laser scan cloud. And of course, there is a value in doing these pipe runs. And I want to mention pipe runs. What we're doing is we're actually modeling the linear piping, including the elbows of the runs, and then we're coming back, as we see in the second bullet down, major bullet, to Cyclone to actually finish these piping systems. In other words, fittings, valves, inline components. Within Cyclone, simultaneously as we're beginning the Edgewise, doing the pipe runs and the steel, we'll have a team working on equipment, modeling equipment in Cyclone, modeling trays and concrete stairs, ladders, all those other things that are involved. We're using Cyclone to actually do a lot of that modeling. And then eventually, like I mentioned, the pipe will come back as soon as it's ready to go relative to the final detailing, as we call it. Our primary deliverables, and I've already mentioned this, is predominantly PDMS. And so there's a process that we have to go to get it into PDMS. I won't go into that detail. However, in a few slides, I'm going to talk about an Edgewise capability that we are heavily using for structural steel and PDMS. Next slide, please. I'm going to take a few minutes to talk about a few examples. And this project here was actually the first project that we used the Edgewise software in. And so this is actually a chemical plant. And in this situation, we modeled all the piping, conduit, structural steel, and just like I talked about before, and then integrated Cyclone to actually complete the process at the end of it. And you can see all the detail. The terrain was done actually in Cyclone using a coarse tin. Basically, we're using a grid of somewhere in the order of 10 to 15 feet on the grid itself. And the lessons learned or the challenge right off the bat is you can model about anything you want in both Cyclone and Edgewise, of course. And so it's staying within the scope of the model scope of what you need to model. So keeping your limits regarding what you're going to model, don't just keep going because these laser scanners will have a long range. Keeping your limits of what you're modeling and then limiting to the what is the scope of, like, for example, how far down you're going to go in the piping is a critical thing on all jobs, but especially we find in ClearEdge 3D because you can just have fun modeling away on the piping and miss the whole point of what we're trying to deliver to our client.
Sure.
Next slide, please.
I can't count the number of times I've gone through and modeled a pipe run and gotten to the end of it, and then I look at the actual, specs and information about the run, and I realize it was like 1 3/4 inches or 1.5 inches, and it was completely out of the scope.
Exactly.
And I just went and modeled the whole thing because I saw it in the point cloud. That's just something you really have to be vigilant about because you just have this tendency, you see a pipe in the point cloud and you click away and you just waste your time.
Yep. We're not making cartoons, or at least in our situation, or enhanced visualizations. It's for engineering usage and design. This is an example that's actually in PDMS. It's again, we do a lot of chemical plants. The structural steel in this situation and the piping again was done. The piping runs were done in Edgewise. Some of the challenges again was to bringing people up to speed because it still was earlier on in our experience with Edgewise, and so we wanted to get more people using the product. In this particular client has a lot of specific ways he wants his model broken up relative to layer structure. In this case, it's PDMS, so we're talking they have sites and zones, and everything has a certain naming convention. And so, like many of our clients, they have specific ways they want their data delivered into their 3D model, and so it's managing that as an interesting thing. And of course, the ductwork, which is large bore, was all the runs were initially done in Edgewise. Next slide, please. This slide is another chemical project. As you can see, there's a large amount of steel. There's actually two identical structural steel two identical structures that you can see, and they are essentially identical. And so this was our first situation where we got to use Edgewise regarding the pattern extraction, where we literally built one structure and then built a column on the other structure, and then said these two columns are the same, and then let it go to work. And it does a first pass that's pretty good, although you got a lot of cleanup. It saves a lot of time in being able to use the pattern extraction to do this type of thing. Also on bridges too, we'll use the pattern extraction. Again, this is not a finished model, so you're going to see a lot of cylinders that are out there, large ductwork, and this would all be finished off in the Cyclone software as far as the detailing. In this project, we had an interesting problem in that there was a detailed plant survey monument system or benchmark system. They were all in about a foot down under small, almost like manholes, but they're smaller, of course. You'd open the lid and there's your monument. And we had an interesting problem where the monument coordinates just weren't matching the documented position of these in the plot plan. And so and this is very common, to be honest. And so our QA sheet automatically catches it. It doesn't automatically, but we catch it in the QA sheet. And from there, we have the discussion with the client. Well, how do you want us to position this? Because these I think there was about 4 plant monuments that were nearby, and they didn't seem to match the position of the coordinates that were shown on the plot plan. And so we had to address that. And that pretty much, it was an interesting project, a large one. And if you go to the next slide, there's a PDMS model of the ultimate deliverable. So this is just one small area. As you can see, it was a long pipe bridge that went by a tank farm and all the way over to a rail location for loading of and unloading of product. And so that was the completed model for that particular project.
Sure.
Next slide, please.
One thing I want to kind of note here is the pattern extract tool. While it kind of to the untrained eye may appear to just be an array tool, it actually intelligently fits each structural object against the point cloud in the kind of the copy area. So even though you basically essentially copy the structure over with the pattern extract tool, the position, the rotation, both from vertical for a column or horizontal from a beam, and sectional rotation is all kind of uniquely determined for each structural object and the pattern, which is kind of really just enhances the strength of the tool there.
Sure.
You can array any tool on the market. It's I of course have to plug Edgewise here. It's Edgewise will intelligently fit every single object in the pattern, and if there were 3 or 4 or 5 of these structures repeating one after another, then all of them would have been extracted, scan data willing.
Yeah, and I'll point out there is some cleanup. I don't want to say it's automatic. You had one structure and here it is. So there's members you've got to adjust. There's members that didn't get added because the points weren't sufficient on the second structure. But generally speaking, it's a very good first pass, and then you're cleaning up and adding and making it match what you see in the cloud.
Sure.
And I'm suspecting a lot of this technology was probably utilized somewhat in Verity, but I'm just guessing that your how you guys are extracting members intelligently. It just seems like it may be a fit, but that's my guess.
Yeah, no comment.
Okay. Next project. Go to the next slide, please.
Sure.
This is so small. I just want to show. I mean, I've shown some big ones and bigger ones, larger ones. Well, this is a very small area that is a spaghetti junction of piping, and the client they just couldn't follow everything, and so we scanned the area. It was hard to actually get clean scans everywhere to be able to see all this thick piping, and so anyhow we scanned it. Then we of course imported it into ClearEdge and generated the pipe runs and did the structural steel again, and then completed the process in in Cyclone. One of the complications on this one, there was a lot of steam that we were having to look through, so it wasn't just noisy enough because of all the crap you had there. There was a lot of steam contributing to the noise, and so we had to work our way through that also. And but we got it to them in a hurry. It's a small area, but it allowed us to do it quicker.
Sure. Did you use the BLK on this one? It's a pretty congested area.
No. Actually, we didn't have the BLK. It was just before we got it. Our BLK we purchased in January of this year.
I see.
And so last year. So we used our regular scanner.
Yeah, it'd make it
and
hard.
This client also wanted. They required us to survey, per their specs, plant specs. And although we could have done that, we put targets out there and used the BLK, but, of course, we had a survey instrument on site also. Okay.
Sure.
Okay, what I'm going to talk about now is this. I mentioned before about structural steel, about bringing in, utilizing a relatively new, I think, Edgewise capability for PDMS, and that's bringing structural steel into PDMS. This job was one of our early implementations, so it was a little bit of a learning curve. And we were also working with the Edgewise people on refining how this application worked to allow it to be more flexible for the various catalogs customers may have as far as structural steel catalogs in their system. And so, through the process of working with them, what you're seeing here is the steel was actually modeled within the Edgewise software, and then it was imported, what's called a .pdms C3, I think it is, file is exported, and then we used, if you look on the menu at the top near about the center, you can see the Edgewise menu item, and from that you launch a form that allows you to do the intelligent import where it pairs the steel. It takes the steel catalog that's in Edgewise and pairs it to the active PDMS structural steel catalog, and then gives you tools to resolve what's going to be obviously items not matching, and so it allows you to do that all within their forms. And if you go to the next slide, I'm kind of showing those forms, and only thing I'll point out is what you're seeing on the slide to the right upper. At the lower end, you're seeing these items that were bad profiles, is what the product calls it. And what it allows you to do, and you can tell here, for example, it shows L 2.5 by 2.5 by 3/8. Well, the actual PDMS catalog for that item uses the fraction indicator for the leg of the angle. So this allows you to quickly make those determinations and then alter it so you don't, you can bring it in and cross-reference catalog items that didn't necessarily match. And what allows you on the bottom form you're seeing is whatever catalog that is active, it allows you to set those so that you're now dealing with a specific catalog. Of course, you have many catalogs, structural steel catalogs, different countries, different codes. And so this allows you to quickly set whatever catalog you want to make active to bring that structural steel information in. One of the reasons we want to do this is that within our PDMS design program, what we have is we have pipe hangers and supports program, And one of the things it requires is the ability to be able to pick, like for example, a rod hanger is to pick a structural beam, for example, that you're hanging off of, but it needs to be intelligent. Then pick the pipe, and then it automatically models all the piping components. So having intelligent structural steel is a big deal, because what if you don't have that and you just have some primitive, what the engineer used to have to do was to model a small section of structural steel right on top of the member that's, you know, just big enough to be able to pick it. So he's having to remodel and put a piece of intelligent structural steel to actually allow that application to work. And this means that they don't have to do that. And plus, when it goes into other products like Navisworks, when they hover over it, you're going to see the actual section size because it's catalog based. So it's a very good tool that we use a lot. Next slide, please. What you're seeing here is a very large job that kind of grew on us. And you can see the congestion here. And this is multiple models that are piping models, piping conduit models that are within Edgewise. And this went over a number of months in how we worked this and how the scope kept adding and growing and growing. But you can see the amazing amount of work that can be done, even down, you may be able to see it on the upper right, even down to like handrails that of course are cylindrical in this case, not angles. So you can see that how large or how extreme quantities can be modeled within the Edgewise system. Of course, what we did was we actually isolated down this very long building. It's a paper mill. So many bays within one region, and then so many bays to the next region, and kind of worked our way down that way, and then used these scans to allow us to connect all these together too. So we would bring in one region's piping and make sure it connected well to the next region, things like that. And so you can see how much you can do. If you go to the next slide, it doesn't look as impressive in this next slide, but this is that piping, and there was two major structures, and it's just the piping turned on, not all the other stuff we modeled. And there's also stuff on the outside going across some bridges, but they didn't want us. That would have been the easy thing, the bridges, but some of that spaghetti mess, and that's piping and conduit that you're seeing there.
Sure. What's the minimum size here?
In here, the minimum size was 2-inch.
Wow, that's still
yeah,
pretty dense.
So
I can't imagine.
We at least had that break.
Yeah.
Yeah.
If that had been down to 1 inch, you'd spent probably twice the time on it.
Yeah, and this was it's in the U.S. this facility, but it was done by a manufacturer in Europe who heavily used conduit rather than cable trays. So there was conduit everywhere, and actually a lot of it was large. So it's beyond 2-inch, but it would have been. You're right, it would have been terrible.
Oh man.
Okay, next slide. And I've just got a couple more slides. So just a real quick overview on some of the user tips if you're using Edgewise. What we try to do is limit no more than 100 high-resolution full dome scans for any single Edgewise database. We find beyond that, the performance will suffer a little, at least on our equipment, and it just works best for us to stay within that range. The other thing too is we've written a program that allows us to identify scan numbers that are within the same region. So you want to make sure all the scans in any group of process scans are all next to each other. You don't want one straggler that's 100 yards down the way, and you want all the scans within that group to be next to each other. So we have a simple little program that takes the positions of all the scanners and then helps us volumize those regions and the scan numbers that are associated with them. Overlap adjacent model areas. All I mean by that is that in this case I just talked about, we had a very long building. We wanted to make sure that we had scans that overlapped between those regions so that we made sure we had good coverage to be able to validate the continuation of piping. What we have done too, I talked about staying within limits on that first example I had. We will tend to either try to model columns within the Edgewise when the guy's doing piping, maybe 4 columns just to set his limits so he knows I'm not going any bigger than that. And I'd note this later here, but we also delete any piping below the diameter range, well below, because you're not going to have some that are actually the diameters, not some of the, what we try to do is, for example, if you're doing 2-inch piping, we'll be down around, 1.5 inches. Anything below that gets deleted before we even start doing the piping. And then we also delete anything beyond the limits. So we keep the guy contained within the area he's supposed to be modeling. One of the things we found that's handy is we'll set the pipe model display to layer, and you can just right click and set the display. And then what we'll do is, as we complete a system or group, we'll rename the layer like P for pipe, or C for conduit, or HR or H for handrail. And what will happen is, if you're setting the color by layer, the color change will occur, and you can tell by color what you haven't looked at yet. So it's just a quick way to kind of work through all the piping you've done and not done by using that. I've already talked about deleting auto-generated cylinders outside our area. We use the draggers, steel side draggers on steel, and the top of steel. It's a new tool in 5.2, top of steel, bottom steel alignment tool for structural steel. Incredibly nice in how that works. We utilize, where possible, if we are, for example, with structural steel, if we have structural steel drawings and we want to know the precise size, if we happen to have plant drawings, structural steel drawing, and they'll show a size, we'll make sure in Edgewise we enter that size, because it'll be more accurate than the point cloud scan as far as the actual precise, structural steel size. And one of we feel stupid about this, but it was multiple projects after we had started using Edgewise. There's a handy little thing called recovery button. And there was always a few choice words that were used when we crashed occasionally. And like, uh-oh, we got to start over from my last save. Well, that recovery button was auto-saving. And by pressing that, we didn't lose much. And I'll say something about your software. It seems to be a lot more stable. We don't get crashes anymore like we did when we first started with it. So it's definitely progressing in a very good way.
Yeah, we do our best with that. Anytime we see a crash, we try and squash that bug real quick.
Yeah, it's a rare event these days. Okay, just kind of summarize, this is my last slide, the value we're seeing out of the Edgewise software is that what we have found is we feel like we can safely say we're getting about a 25% reduction in our 3D modeling work hours when we're delivering 3D models. I should point out that many of our projects are scan data only. So in that situation, we wouldn't be using Edgewise or 3D modeling. But when we're delivering 3D models, it's a very significant savings that we're getting as far as we're concerned, especially the scope on some of these jobs, by utilizing the software. What we found too is you're getting a more complete 3D model regarding to the quality and the coverage that you're some things which you look in other software and you think, I have no idea what's there. Once you look at it after it's been unified, so to speak, and processed into the Edgewise scan database, you begin to see clearly from the faint shadows, in the upper areas that you could hardly see anyhow with your eye, let alone the scanner. You begin to see the routing of pipes. So we found that to be a big deal. Also, there's excellent point cloud cylinder and structural steel fitter. The fitter is excellent. We love also I don't know if you call it a thumbnail, or when you're looking at the profile of the structural steel, you have an automatic thing that pops up, and you can see the point clouds and see how well it fit the structural steel member it's modeled. Let me see. We also, of course, are heavily using, like I just mentioned a little while ago, the intelligent steel import, which is a big deal for us. And then finally, on all this we're doing, we're usually almost always passing, other than the structural steel intelligent import, we're passing the data through Cyclone model, and we have some customized KBR Python tools that we've developed in the Cyclone model that help us be a little more efficient in how we model and do things faster and do a better job. And that pretty much completes what I've got to say.
Excellent. Thank you, Derrel. Before everyone signs off, we are taking questions now, so feel free to type whatever questions you have in the questions box and go to webinar. We already have a few lined up, so let's dig into those. We have a few questions, I think, that were a follow-up to the example you gave of using the BLK in a small area.
Yeah.
And one was, do you survey every scan target to establish the local control to be used by the scans?
Okay, on the BLK, we're generally not using survey. That, again, is being checked out by our engineers. We would ask them to make sure they try to limit the size of the area they're scanning. And what we also ask them to do is to overscan columns, for example, if we're using structural steel to position it. But in those situations where we could put targets up and acquire those targets and survey them. And sometimes what we're doing, we're going back to a site that's already been surveyed and had scans done, and we're supplementing. In those cases, there will be targets that are already there that have been surveyed, and we will utilize them to position the scans. But in the BLK 360, we're really not using target-based registration. We're using cloud-to-cloud, basically semi-automatic through Register 360.
We have another question here, which is, what is the best strategy to scan a 30 meter by 30 meter area with the Leica BLK 360 scanner?
30 meter by 30 meter. Okay, that's about 100 feet or so, huh? So I would, you're at the edge where I would not feel, you're at the edge where I would almost want to have some targets at the extremities of the area that are surveyed just to do a correction. But I think, I mean, if the scans are close together with a BLK 360, meaning between 20 to 25 feet, you have good objects around, flat objects generally. I don't think it'll actually mesh well with curved surfaces. You may be okay at that extent, but it would be definitely pushing the outer edge where I would take the instrument. My recommendation would be I would scatter a few targets in there, get a local survey in there to survey those targets, acquire those targets, do cloud-to-cloud registration, and hopefully what will happen is you'll get a low error residual on those targets when you actually bring the targets in to position the group. That would be my suggestion. We would definitely not, I wouldn't recommend going that far without some survey, although it's possible you may be okay. It's just I don't know how much error accumulation would happen during that distance.
Sure. I guess it also depends on how densely packed that area is and how much line of sight you're going to have.
And admittedly, too, if you're starting from the center and going both directions, you know, your error from each direction, you're only then, you know, talking 15 meters. Mm-hmm. You're probably good, the more I think about it. But I'm thinking more of a linear run. If I started at 0 and went to 30 meters, then I would possibly want to have at least a target or two at the end just to confirm that I wouldn't have any kind of deviation that's going on. And you may not at that length.
Sure. When you model a straight pipe run, as per the point cloud, is it sloped or having sagged portions in the model? How does Edgewise model it? What is the minimum value to ignore the deviations? I think I can answer that one pretty well.
Yeah.
Basically, the minimum value to ignore the deviations is set by the user. We have something we call the clean pipes tool, which is an innocent enough of a name, but it actually will kind of recalculate the pipe segments in the pipe run based on a tolerance to, if you have a half-inch tolerance, it's going to ignore every deviation smaller than half of an inch. If you have a 1 meter tolerance, you need a 1 meter deviation or greater for Edgewise to model it. So we have tools to automatically fine-tune basically the level of detail in the pipe model there. Some people want every little detail modeled. Some people want a mostly straight kind of as designed model. So we support kind of everything in between. Of course, the level of detail we extract by default is relatively fine-grained, but you can fine-tune it from there based on your needs.
And that's one feature we've really liked, in that we can account very easily for sag, both vertical and horizontal in systems, and decide what we want to use on the tolerance because, like you said, sometimes you want a linear run, and sometimes you want to be a little more accurate relative to the droop due to gravity or what may be going on with the line itself.
Yep, absolutely. One here is, what do your Python scripts for Cyclone do? What exactly do those entail?
Okay, what we've got is scripts that help us with building platforms, handrails, stairs, scripts that allow us to quickly model, like, for example, electrical trays. We even have on one of them a catalog of electrical tray sizes, which actually hasn't worked that well. It turns out every electrical tray fabricator or provider has their own dimensions on the outer length of a tray. So we use it for that type of thing. Do foundations. One of the things we're still trying to conquer right now, and it's not easy, is how to handle inline piping components. If we can figure that one out, that would sure simplify and save a lot of time if we could somehow automate that. And I know you can use libraries within Cyclone Model, and we do, but we would like to be able to pick and place through a catalog, and so we're working on that one.
Sure. That kind of leads into our next question here, which I promise I wasn't the one who typed it. Why do you use both Cyclone and ClearEdge?
Well, and I may be corrected on this one. So what we find is that the ultimate finished product regarding the detailing, for example, on the piping inline components and all the other things like building equipment, we find it better to use Cyclone to do that finish work. And I'm open to somebody showing me different, but at least from our experience at the moment, that's our workflow.
Sure, I can speak for Edgewise a little bit. Generally speaking, our philosophy is to, for the example of a Revit model, because that's just what comes to mind, is the Revit family objects we make for valves, flanges, all your fittings are relatively simple. They're kind of made to be, because everyone's going to have their own Revit family objects. I'm sure in PDMS everyone's going to have their own specs, on and on. They're basically made to be switched out for whatever you have in the kind of the target application there. And that's generally our philosophy, is we give you the tools to quickly flip it out and define the information you need in the end platform, rather than do a bunch of the detailed work there in Edgewise, where our focus is on as-built modeling, and there's plenty of really good applications out there for very kind of intelligent BIM or plant modeling and getting all those specifications right. Of course, some people find it easier just to place those things in the end application instead, but
yeah.
Let me find the next question here. What is the performance of Edgewise? What are the optimal requirements for the PC? How would you characterize your Edgewise?
Well, I probably, compared to most people, our KBR provided hot machines are probably not as hot as what some of the guys out there who have the ability to buy whatever they want. But I would say on a high performance, i7 type processor with a 32 gig RAM and solid state drives, we're getting excellent performance. But I would say that, like I mentioned before, we've made the mistake. One time we tried to put in 400 scans, high resolution full dome scans, into a single Edgewise model, and we had some difficulties. And so the balance, we felt after some testing, was 100 max seemed to be a good number as far as the upper limit, and we're usually under that. But that's how we try to balance it. But I'm not sure if I answered the question, but that's how we do it anyway.
Sure, I can, for kind of the optimal setup there, anytime you're working with point clouds, so much of it is going to be kind of bound by the disk, right? Your read speeds, your write speeds, your storage space. Typically, I find that PCIe connected solid state drives, like the M2s that are becoming very popular now, are going to, for the money, you're going to be the best on the market. Your They're faster even than the static connected solid state drives, which is going to do you a lot of favors when you're processing, hundreds of scans at a time, because it's just that performance really is going to stack up in your favor. Other than that, Edgewise typically for most of its automated processing is multi-threaded. Intel is now coming out with their i9s with 8, 10, 12 cores, which is of course 16, 20, 24 threads, which is definitely going to drastically speed up your processing time there as well. You're going to want a dedicated graphics card, but we're not doing real-time ray tracing or anything extremely complex in terms of real-time rendering. So long as you've got a decent graphics card, I think you'll be all right. Next question is, when we're connecting two adjacent areas, I assume he's talking about when you're splitting up your model into multiple segments there. How do you treat the differences? How do you know when it's areas of common procedure and accuracy? So basically, if you hand that off to two different modelers, I guess, and the two ends of the pipe run don't line up at the end, how do you resolve that?
Well, what we'll do is I'm just going to make an assumption on what's being asked. That, for example, if you're looking at OD of the pipe or the cylinder, if you're going with, one's going to, based on its points, going to calculate it different than the other. We try to resolve that with what would be a good, make them both the same, based on, what would be a good OD, that would represent both. And and that's one of the things, by the way, the chain information that's done in Edgewise is fantastic. That you're basically picking the entire chain and changing the diameter down the length until you hit a discontinuity or a reducer or something like that. So that's how we handle it. I don't think he's referring to the scan itself, because the scan shouldn't have it. So I assume it's the model only, and we're talking about piping. And we essentially don't see any issues with the position of the point cloud relative to the pipes.
Yep, that is an important.
Might have a slight deviation, admittedly, because of the fact that the best fit on a cylinder on this group, and best fit on the other one, there may be a minute difference that will just resolve in the connection between the two.
Right, but the important distinction there is that for the entire registration process, all these scans are being registered together despite being split up for modeling. So in terms of the overall position of the pipes, there should be no error outside of the registration error.
Just outside of the normal real-world piping skews that go on, as you roll down the length.
Which is never.
But yeah, you're right. Yeah. Well, yeah, you're right. It shouldn't be side by side.
Yeah. All right. One here. Have you used the Leica RTC 360? If yes, is it hitting the specs published?
I haven't, and I'd love to, but I haven't. Admittedly, one of the only concerns I have for that instrument is its long-range ability. But having said that, my understanding is within 100 feet or so, it's just as good as our P-series scanners. Talking to friends that have actually have had a system loaned to them to test, they're very impressed with the system. So yeah, I'd love to get my hands on it. Lucky people out there that can get those.
Sure.
That's bad. There's one other thing too. Let me just jump in. The way that it takes like 5 exposures on the camera, we have a tendency to use exclusively almost grayscale because of the lighting, contrast, and all the complexity of photography and photo draping the points. That one of the things I'm so impressed with that unit is its ability to take the best out of multiple exposures to actually drape the photo across the point cloud.
Sure. One last question here. We're rolling right up on 2 o'clock, and we do want to be respectful of everyone's time. Do you see any future in the SLAM products? Of course, SLAM being the kind of registration methodology there you were mentioning before of circling back around. Yeah.
To be honest, I can't really comment because I don't feel like I know enough about that. It's definitely something I need to research. I'm sorry, I can't really comment.
Oh, that's quite all right. Well, I think we're about wrapped up here. There are a few questions that we did not get to live on the air here, and we'll do our best to follow up after the webinar here. But of course, Derrel, thank you for your time. I know you're quite a busy guy, and for all of our attendees, thank you for joining us as well. Hope you found it very informational and insightful, and hopefully we'll see you all again next time.
Thank you.
All right. Thank you everyone for joining, or we're going to be ending the webinar now.